Page 17 of descriptive statistics, only for HL. So, number 8, a set of 8 integers, these integers here, has a mean of 5 and a variance of 5.25. If you remember, mean is sometimes written as mu, Greek letter for m, and variance is sometimes written as sigma squared. Find P and Q given that P is less than Q. Okay, so basically we have we can use the summation of all these numbers here, and so we can add all the numbers in the numerator, and then we divide by the total number of numbers. So if we do that, we can see that we can add the known numbers, 1 plus 3 plus 5 plus 7 plus 4 plus 5. That would be, let's see, 4, 9, 16, 20, 25. So that would be 25 plus the two unknown numbers, plus P and plus Q. How many numbers are there total? 1, 2, 3, 4, 5, 6, 7, 8 numbers. So we know that this is equal to 5, right? The variance is 5.25. Now the variance is calculated by subtracting each number from the mean, and then squaring it, and then dividing that by n. And it can also be calculated by squaring the number and taking the average of that and subtracting the mean squared from that. I think both of these formulas are on your formula sheet. So let's do this quantity here. So that would be 1 squared, which is 1, 3 squared, which is 9, 5 squared, which is 25, 7 squared, which is 49, 4 squared, which is 16, 5 squared, which is 25, and P squared and Q squared. Okay, so let's add those up. 1 plus 9 is 10, 10 plus 25 is 35, 35 plus 25 is 60, 60 plus 49 is 109, 109 plus 16 is 125. So we got 125 plus P squared plus Q squared divided by the total number of numbers, which is 8. And we can subtract the mean value, which we know is 5, squared. Okay. Now we could solve these equations using the calculator. So I'm going to write them as linear equations. So let's multiply both sides of this by 8. So we could get 40 equals 25 plus P plus Q. Subtract 25 from both sides, and we'll get P plus Q equals 15. Okay, so that's one of the equations we're going to use in the calculator. The other equation is going to be 5.25 here. So 5.25 plus 25 is going to be 30.25. So now I'm going to multiply everything by 8. So if I multiply the left side by 8, I'll get 242. And if I multiply the right side by 8, then I'll just get 125 plus P squared plus Q squared. Now, let's see. The best way to solve these two equations is to put them in the calculator into y equals. So let's see, we're going to put, let's say that P is x and Q is y, so we'll say Q is equal to 15 minus P. And then here we'll say Q squared equals 242 minus 125, which is 117, minus p squared. So q is equal to the square root of 117 minus p squared. So let's put those two equations in the calculator. 15 minus x and square root of 117 minus p squared. Okay, and then we'll graph. Okay, so we got two functions intersecting each other. One of them is a circle, of course, because this is a circle, and the other is a line. Let's do a zoom fit, see where the intersection is. Oh, it's like a little tangent line almost. Let's zoom in a little bit. So we'll do 0 to 10. Okay. Let's zoom in a little bit more. Yeah, it definitely intersects twice. So let's do a second calc intersect. And the first curve is the line. Second curve is the circle. Our guess is, let's do this guess first. The intersection is 6, 9. Well, all that work with the calculator, and it's a whole number. And the other one is probably going to be 9, 6. Let's try. So we'll do second calc intersect, and we'll move it closer to the second intersection. Hit enter. And it's 9, 6, yeah. So either 6, 9 or 9, 6. Now, remember it says that p is less than q, so p is going to be 6 and q is going to be 9. Right? 6, 9. Okay? Alright. You could probably have done that with algebra, as they're whole numbers, but it's okay to do that with the calculator. On the test, that would be a calculator problem. Number 9, a set of 10 integers, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 8 of them are known, 2 of them are unknown. Has a mean of 6 and a variance of 3.2. Find A and B, given that A is greater than B. Okay, so this is a similar problem to the other one, right? So let's see. 3, 9, 5, 5, 6, 4, 6, 8. So for the mean, what we're going to do is we're going to have, as we had above, we're going to add up all the known numbers, and then we're going to add up A and B, and that'll give us, and divide by the whole number, the number of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh yeah, it's 10. So it'll be 3 plus 9, which is 12, plus 5 plus 5, which is 22, plus 6 plus 4, 32, plus 6 plus 8, which would be 46, plus A plus B, divided by 10 equals 6. And what I'm going to do, I'm going to multiply both sides by 10. So I'll have this is equal to 60. And then I'll have A plus B equals 14. A plus B equals 14. And then I'll do the variance. I'll add up the variance. So the variance is going to be 9 plus 81 plus 25 plus 25 plus 36 plus 16 plus 64. Oops, and I missed a 6 there, didn't I? 36. 9, 81, 25, 25, 36, 16, 64, and 36. Okay. I'm going to add all those up with the calculator. So, clear. So it turns out that when you add all these numbers up, you get 292 plus a squared plus b squared divided by the number of numbers, which is 10, minus mu squared. Mu, remember, is 6. So mu squared would be 36 equals 3.2. Now let's multiply everything by 10 so that we get that out of the denominator, and we'll have 292 plus a squared plus b squared minus 360 equals 32. And let's move all the numbers to the right side. So we'll have 360 minus 292, which would be 68, plus 32, a squared plus b squared. 68 plus 32, that's equal to 100. So a squared plus b squared equals 100. Wow, that's a circle with radius 10. And we also know that b is equal to 14 minus a. We can solve this with algebra this time. So let's substitute b equals 14 minus a into our new equation. So we'll have 14 minus a squared equals 100. And then, so we'll have a squared plus 14 squared minus 28a plus a squared equals 100. Let's make this into a quadratic. So we'll have 2a squared minus 28a. 14 squared is going to be, is it 250? No. It's 196. So 196 minus 100 equals 0. 196 minus 100 is 96. 2a squared minus 28a plus 96. We could divide everything by 2. We get a squared minus 14a plus 48. Okay, we'll put our coefficients into polysMLT. 1, negative 14, 48. And our roots. Oops. It's not minus 14. It's negative 14. Negative 14. So our roots are 8 and 6. So we're going to have a plus 6 and a plus 8 equals 0. Or not, it's a minus 6, a minus 8. So our roots are 6 and 8. Okay, so basically, which one is bigger than the other? A is greater than B. So A is going to be 8, and B is going to be 6. Okay, so that's all we need to do for that one. Last one, 10. Prove that. This is the formula for the variance, except it's not divided by n, is equal to this. Okay. And then find the mean of the data set, blah, 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 given that this is equal to this, and standard deviation is 5.2. So basically, this is the formula that we've been using to simplify the variance. So this is the definition of the variance, and we found out that this this expression here, which is a little bit easier to use, is equivalent. So let's try to prove that. So first we're going to start with the left side. And we see a binomial squared, which makes me want to FOIL, right? So let's FOIL that. So sigma xi squared minus 2 mu xi plus mu squared. Okay? And then we're going to distribute the sigma. So we'll have sigma of xi squared minus 2 mu, and sigma of 2 mu xi plus sigma of mu squared. And if you notice here, mu is actually equal to sigma. It's a number, and it's equal to sigma of xi divided by n, right? So we're going to put mu on the outside of this, and then we'll put the 2 on the outside too, and then we'll put the sigma and the xi here. Okay. So now we have this. Okay. So if I take this expression here and I multiply it by n over n, which is just 1, I could make this times this times n, right? So I've basically replaced sigma xi with sigma xi divided by n times n. Okay? Now I can see that, hey, I actually have mu times mu times n times 2. So if I have mu times n, that's the same thing as taking the sum of mu squared, because if I do the sum of mu squared, that's going to add up mu squared n times. So this part here simplifies into sigma mu squared. And this is plus sigma mu squared, and this is sigma xi squared. Now if you combine these two, they're like terms, you can put sigma xi squared minus sigma mu squared. Or, yeah, actually, instead of putting sigma mu squared, we could rewrite that as minus n mu squared, right? Because, okay, now let's see if we got what we wanted. Sigma squared minus n mu squared. We did. Okay? So we showed that. Then it says to find the mean of this data set given that the variance is 5.2 squared and sigma xi squared is 2568.25. So we're going to take this equation that we just proved, and then we're going to substitute in for the left side, it's the variance, so we're going to put sigma squared there. And the right side is going to be sigma xi squared, which is 2568.25, minus n mu squared. And now let's solve for mu. What's n again? So n is going to be 25 because we're subbing from 1 to 25. And then we'll put that there. And then we'll rearrange it. We're going to put that on the left so we don't have a negative sign anymore. So we'll put 25 mu squared on the left. Then we'll have 2568.25 minus 5.2 squared. What's 5.2 squared? It's 27.04. So let's subtract 2568.25 minus 27.04. We get that. Oops. We get that, and then we're going to divide both sides by 25. And so we'll get mu squared is equal to 101.6484. And if we find the square root of that, it's equal to 10.08. So that's it.